I'm also 50 years old. In this lesson on limits calculation, we are taking a look at this example we have over here. When you show that 12 over 11 multiplied by 12 over 13 multiplied by 24 over 23 multiplied by 24 over 25 multiplied by 36 over 35 multiplied by 36 over 37 and so on. This is equal to square root 6 plus square root 2 multiplied by pi divided by 12. Right. So since this is the example we have to solve here, what do we need to take note of first? So the first thing you might realize is all of these fractions, they are somewhat close to 1. Just a little bit over 1 and a little bit under 1. So all of these numbers are close to 1. And when all of them multiply together, somehow gives you an irrational number. So that's one of the first things you might realize. So is this right? Let's take a look. So for this number here, how are you going to start solving this? Right. So if you want to express it in a limit form, you can have limit. Let's say n approaches to infinity, and then you express this in a pi notation. And let's say you're using I for whatever you have inside the pi notation. So I, you can have it start from 1 and make it reach n. Alright? So how is this pattern going to be like? Well, it is going to be 12i divided by 12i minus 1 multiplied by 12i divided by 12i plus 1. Alright, so this is what you can see it as. Now, how would you proceed from here? Well, once again, you have two different ways that you can take a look at this. It is either you directly use the Wallace product from this step, or you change I into make it start from 0. So limit n approaches to infinity, and you have a pi notation. I start from 0 until n. So I starts from 0. What you have is I plus 1. Since at the same time while you're doing this, you can also divide 12 on both numerator and denominator for both of these fractions. So I plus 1, and below here, originally it is 12i plus 11, which becomes I plus 11 over 12, then multiplied by I plus 1 and I plus 13 over 12. Right. So this is the fraction that you're going to see over here. Next up, we are going to use the gamma function, or you might just know it as the Wallace product, right? So changing this form into a gamma function, what we're going to see is gamma 11 over 12, gamma 13 over 12 divided by gamma 1, gamma 1. Well, in order to use this, you of course have to make sure that this is 1 plus 1 is 2, and below 11 over 12 plus 13 over 12 is 2. Alright, so this will be the form of gamma functions that you're going to see. Next, you can use a property of gamma function for the part behind gamma 13 over 12, which is equal to 1 over 12 multiplied by gamma 1 over 12. Right, so that's one of the properties of gamma function. So now that we have this term here, what we're going to use next is the Euler reflection formula. Euler reflection formula, where we're going to change this into pi divided by 12 sine pi over 12. Alright, so this is what we are going to see with the Euler's reflection formula. Right, so isn't that just our answer? How are you going to convert it into this term here? So from this step onwards, we have two different methods which we are both going to use. Now, method 1. What you can take a look at is separating this sign into different parts. So what exactly do I mean by that? Now, sine pi over 12. how can you separate this pi over 12 into two different terms? So of course, if you have learned trigonometry or just basic fractions, you can separate this into pi over 3 minus pi over 4. So this becomes sine pi over 3 minus pi over 4, which then you'll use one of the trigonometric formulas, and you have sine pi over 3 cosine pi over 4 minus sine pi over 4 cosine pi over 3. And this will give you, so sine pi over 3, that's square root 3 over 2 multiplied by square root 2 over 2, then minus square root 2 over 2 multiplied by half. Okay? And this is going to give you square root 6 minus square root 2 over 4. And now when you put it into the fraction, which will get pi over 12. So now it is 12 multiplied by square root 6 minus square root 2 divided by 4, which will have pi over 3 multiplied by square root 6 minus square root 2. And then you will use denominator rationalization to get square root 6 plus square root 2 in the numerator with a pi. And then 3 multiplied by 6 minus 2, which is 4. Or you could immediately just get 12 in the denominator. Alright? So this is divided by 12. Alright, and there you get the answer that you have. So this part is equal to square root 6 plus square root 2 pi divided by 12. Right. So since this is just the first method, we can take a look at the second method. So what will be so special about this second method? So what are we going to use? We're going to use the double-angle formula. So the double-angle formula, we're going to have sine pi over 12 is equal to square root 1 minus cosine pi over 6 and then divided by 2. So square root 1 minus cosine pi over 6 divided by 2. What are we going to have here? Now, cosine pi over 6, what is so special about that? Well, of course, we do know its value. Well, you have square root 1 minus square root 3 over 2 and then divided by 2. Alright, so this is what we have. Now, the next step. We can take two of these divided by 2's out into over 2. And then in the numerator, you have square root 2 minus square root 3. But at this step, you might be wondering, how are you supposed to continue? Alright, so actually, at this step, here comes the little bit of trickiness, if you might realize it. So how exactly is this trickiness going to work? So let's say you have pi over 12 sine pi over 12, and then when you substitute whatever we have in this part in, you're going to have pi divided by, so 12 will be multiplied by that, and you're going to have 6 square root 2 minus square root 3. So all that you need to find next is how are you going to make 2 minus square root 3 into something squared, right? So how are you going to achieve that? Well, the first step, you might want to try to multiply inside by 2 if you can't solve it just yet, since if you want a square, you do need something that's of multiplied by 2 in front, right? So if you multiply this by 2, you're going to need another 2 in the numerator. Or you could also just put a 2 from the 6 inside, which is going to give you 3 in the denominator. So 3. And then you have square root. So put the 2 inside, which becomes multiplied by 4. We're going to have 8 minus 4 square root 3. Now we take a look at it again. Does it seem a bit more simpler to find? Well, if it isn't, let's try to continue. pi divided by 3 square root 8 minus 2 square root 12. Alright, so is there any chance we can find it out? Well, of course, this might take a bit of experience once you have done enough questions, but if you can recognize this is essentially you have a square root inside, and then 8 minus 2 square root 12 will just become square root 6 minus square root 2 squared. Can you see that? Square root 6 squared, 6 plus square root 2 squared, 2. So 6 plus 2 is 8. And then you have minus 2 of square root 6 times square root 2, which gives us square root 12. Alright. So the next step, well, you just take it out of this square root. We're going to have pi divided by 3 square root 6 minus square root 2, and then use rationalization on this to get square root 6 plus square root 2 pi divided by 3 multiplied by, well, what are you going to have here when you rationalize it? So you're going to have 6 minus 2, which is 4, which is 12, right? So there you have it, two different ways to get the final answer. But of course you can also split into a lot more than two ways, since there are many different ways of representing whatever you had in front here. Right, so let's take a look at the kind of methods we've used in this example here. So firstly, we want to try to write everything into some kind of a pi notation. And with this pi notation, make a little bit of simplifications, modifications, then use a Wallace product, changing the gamma function form. With a gamma function, you can use one of the properties of gamma function, and afterwards use the Euler's reflection formula. Then from that step, you have two different methods. The first method, which is to use a trigonometric formula, and then separating it, and allows you to give a rationalization. Or the other one, use a different kind of formula, which is double angle formula. And then you have a little bit of modifications, and then at last, once again, you rationalize it, alright? So this will be the answer you get in this example. Right, so I hope for this lesson, you are clear of all these so far. I'll be ending this lesson here, and thank you for your watching.